All right, let's look at part B. We're given the directrix, y equals -2 horizontal line, and we are given the endpoints of lattice rectum, which are 0, 2, and 8, 2. So let me just remind you what a lattice rectum is. Let's say like we have a parabola, hypothetical parabola, whose major axis is vertical, okay? We have so many lines passing through the focus of the parabola. Let's say like the focus is located here. So I can go ahead and have a line passing through the focus and intersecting uh, the parabola at two different instances, okay, here. And I can have another one passing through the focus and intersecting the curve. And these are called like focal chords, okay? Focal chords. All right, so once we have focal chords, we have a very specific focal chord that is in fact perpendicular to the major axis. So that one is what I'm after. It's called lattice rectum. Okay, so this is the one that is perp to the major axis, and we're given the endpoints of the lattice rectum. Okay, this is lattice rectum, and we're given those points here. Okay, and what are those? 0, 2, 8, 2. Okay. Well, first observation here is that the midpoint of the lattice rectum is in fact the focus. And from 0, 2 to 8, 2, there's 8 units, right? The half of that is 4. So midpoint, which is the focus, let me just write that down here. The coordinates of the focus is 4 and 2. Okay? And the y-coordinate, as you see, doesn't change because this is a parabola whose major axis is vertical. Okay. All right. So once we have the location of focus, another property of lattice rectum is that the distance from the intersection point on the parabola to focus on lattice rectum is just 2p. Okay, 2p, and here is 2p. Okay. And in total, the length of the lattice rectum is 8 because that's the distance from 0, 2 to 8, 2. Okay, so this implies that p equals 2. Okay, one property of the parabola is that the distance from the focus to the vertex is p. Okay, so here, for example, if this is the vertex, so this distance is here, just p. Okay. Since we know the coordinates of focus, we can actually write down the coordinates of the vertex. That's only 2 units far below from focus, right? So that's going to be 4 and 0. Okay. All right. So we have the vertex, we have the p. We can go ahead and write down the equation of the parabola, whose major axis is vertical. Okay. So vertical axis here. So we're using this formulation here. Okay, so the vertical axis formulation. X minus h quantity squared equals 4py minus k, and h and k are the coordinates of the vertex. Okay, so let's go back here. X minus, let me just go with this color here, x minus 4 quantity squared equals 4 times p times, okay, 4 times p times, maybe we're running out of this space here, 4 times 2 times, let's see, y minus 0, okay? So in other words, just y, okay? All right, you can simplify this further if you want to. Y equals 1/8 x minus 4 squared is the equation of the parabola where you're given only the directrix. In fact, we didn't really use the directrix here, but we could. So the directrix here is just placed somewhere here. Okay. In fact, why don't we graph this, and I show you the graph, and you can see what I'm talking about. Here we go. Here's the focus, the dashed line here, the red dashed line, having the red dots at the tips. Okay, so that is the lattice rectum, and we have our directrix right here. Okay, and we have the blue curve representing the graph of the parabola. Okay, so this is a better picture of that. All right, so I think that is the end of part B. In fact, it's the end of the whole exercise. So thanks for watching. I'll see you in another video. Bye.